Okay, hello everybody. So today we're going to talk a little bit about your bonding. Okay, this will be the training video for bonding of ionic and covalent structures. Okay, so I'm going to show you guys how to teach these. Okay, so I'll begin now. Okay, hi students. So today we're going to talk a little bit about bonding and structure. So today we're going to learn about things such as your ionic and covalent bonds. So over here, what is important is you will still need to remember the concepts of your ions first to help yourself with ionic bonding. And later on, I will share with you a little bit more about covalent bonds. So let's jump straight into the concept of ions. Okay, so recall that atoms tend to be neutral and have no charge. Okay, so why is that the case? Because they have the same number of protons and electrons, and in this case protons is positively charged and electrons are negatively charged. So if you have the same number, they will naturally cancel out. On the other hand, okay, when atoms gain or lose electrons, they will become your ions, because now the number of protons and electrons will no longer be balanced. Okay, so the main idea of them becoming ions is for them to achieve the electronic configuration of your noble gas. Okay, so it will not be called group 8 anymore. It will actually be called group 0, or nowadays we like to call it group 18. Okay, so over here, what we're going to do here is to actually kind of do a quick recall on how do we get the ions of any elements. Okay, so for example, for sodium, I know that sodium is 11 on the periodic table, so its electronic configuration is 281. Over here, sodium has two choices. He can either gain 7 electrons or he can lose 1 electron to attain a full shell. So in this case, we will always choose the smaller number, and because this guy will choose to lose 1 electron, he will form a plus charge. Okay, so if you guys are okay, please go on and help me to try out the rest of these questions over here. Okay, so at this point in time, give the student some time to do these questions, and then you can proceed on to the next part. Okay, so generally over here, I tend to skip because it's just a repeat of what the periodic table is. If you have already taught students before this chapter, means you have taught them things like atomic structure and all these, naturally I will just skip this page. Okay, so I'll just take it that I'll skip this page. Okay, it's not very important. We will jump straight into what an ionic compound is. Okay, students, so over here we will be looking at your ionic compounds. So what is an ionic compound? To form an ionic compound, you will need a metal and a non-metallic element, and then you will chemically combine them together. When you do that, you will get an ionic compound. So the next question here is, how do we determine the formula? Okay, so prior to this, we have already learned chemical formulas. So for example, if you have lithium and oxygen, we know that lithium will be plus, oxygen will be 2 minus. And when you want to combine these two, you will need Li2O. So you need 2 lithium to combine with 1 oxygen. Okay, so likewise for Mg, you have Mg2 plus and Cl minus, K plus and I minus. So meaning that the formula will be MgCl2 and Ki respectively. Okay, so if all is good, let's take a look here. So to kind of summarize ionic compounds for you, in ionic compounds, somebody will gain, somebody will lose electrons. So in that sense, there will be a transfer of electrons from one atom to another. Okay, so now I'm going to show you a little bit of drawing. Okay, so you can come to this page here. So for example, I have K plus and Cl minus. We know that we will have KCl. So the K will lose 1 electron, right? The Cl will actually gain 1 electron. So over here, there will be a transfer of electrons. So meaning that this electron right here for sodium, for potassium, will join and come here into chlorine. Okay, so how are we going to draw the final product? Okay, the final product, okay, will be drawn this way. So over here, you'll realize that in your K plus, okay, you'll be 2.8.8. Okay, and your Cl minus will also be 2.8.8. But just take note that out of these 8, 7 electrons is from chlorine. Okay, and 1 electron is from potassium. Okay, so remember to show me using your dot and cross. So don't forget your brackets. Okay, so your square brackets allow you to put a charge here. Alright, your square bracket here allows you to put a charge here. Alright. So if you guys have no questions, you guys can actually try the following questions here. Okay, so before letting the students try this part, it will always be good to get them to do out the chemical formulas first in case they forget. Because if the chemical formulas is wrong, then the drawing will naturally get wrong also. So for magnesium chloride, make sure you go through with them that it'll be MgCl2, sodium oxide is Na2O, calcium chloride is CaCl2, aluminum oxide is Al2O3, alright, potassium fluoride will be Kf. Okay, so make sure you go through with them the chemical formulas first, alright, and then you will get them to do their drawing. Okay, so once they have done their drawing, then you can proceed on to the next part. Okay, so for the next part, they will always talk about the properties of your ionic compounds. So you have seen here that I have already written things in advance. Okay, so you guys can actually pause the video to take a look at what I've written. Okay, if not, I'll show you guys and demonstrate how I teach this. Okay, students. Okay, let's come to the properties of ionic compounds. So when it comes to the properties of ionic compounds, regardless of whether it's ionic or covalent, there's always two things we like to talk about. We always like to talk about their melting and boiling point, and also their ability to conduct electricity. So let's focus on the first one. When it comes to ionic compounds tend to have high melting and boiling point. Okay, so why is that the case? Okay, so let me write this down for you guys first, and you guys can copy. Okay, so come, now let me break down what is this sentence telling you about. Okay, so over here you notice that in ionic compounds, there will be strong electrostatic forces of attraction. Okay, so what exactly is this electrostatic forces of attraction? So in ions, we have positive charges and negative charges. In between these plus and minus, there will always be a form of attraction. And this attraction is what we like to quantify as your electrostatic forces of attraction. And this will be very strong. Okay, so over here, what you can conclude for me is that because of this presence of these strong electrostatic forces of attraction, large amount of energy will be needed to overcome these forces. Okay, so once they are done, you can move on to the next part. Okay, students, come. So over here, we're going to talk about the ability to conduct electricity. So for ionic compounds, they're a little bit special. They can only conduct electricity in molten and aqueous state, but not in solid state. So why is that the case? Okay, so come, students, help me to copy the words down first. So in solids, okay, your ions are held in fixed position in a giant ionic lattice structure with strong electrostatic forces of attraction between the ions. Okay, so let me break this down a little bit for you guys. So what do we mean by giant ionic lattice structure? Okay, to explain this, allow me to draw out this diagram for you. So when you look at this diagram, okay, this is actually your lattice structure, right, where in solid state, your particles are all neatly arranged. So for ionic, because it's made out of plus and minus ions, we will alternate between the positive and negative ions in this structure. So you'll realize that between this plus and minus structure, there will be strong electrostatic forces of attraction, and this is what keeps them in place, and the ions will be unable to travel. So if they are unable to travel, we will not be able to conduct electricity. So why is that the case? Because to conduct electricity, what do we need? We need this thing called mobile charge carriers. Okay, so what is a mobile charge carrier? Right, it can either be your ions or your electrons. Okay, so generally these are the two things that we'll be looking at. So why now in aqueous and molten state we will be able to conduct electricity? So this is because in aqueous and molten state, the ionic compounds dissociates into mobile ions. Okay, so what do I mean by dissociate? So let me show you. Okay, so for example, I have NaCl. When you put him into water, you'll get Na plus and Cl minus. Right, so this is the process of dissociation, where ionic compounds break down into their respective ions, and you'll realize now on that your Na plus and Cl minus will be able to move freely. Okay? Okay, so once the students are done here, what you can do is to get them to try the ionic questions. So it will be over here. Okay, so you can get them to try this question here. This is on page 15 and also on page 16. Okay? Okay, if not, once they are done, run through the questions with them and then you will go back onto the covalent compounds. Okay, so when it comes to covalent compounds, what you'll be doing here is to go run through what this content is. So let me show you. So for covalent compounds, okay, students, let's talk about your covalent compounds. So in covalent compounds, you will always have non-metal plus a non-metallic element and they will chemically combine. Okay, so when you get two non-metallic elements together, you will get a covalent compound. So in ionic compound, there was a transfer of electrons, but instead of transferring electrons, now we will do a sharing of electrons instead. Okay, so why do we do that? Okay, it's the same reason as ionic, so that it enables each atom to attain their noble gas configuration. Okay, so let's take a look at how this happens. Okay, so for example, you have chlorine. Chlorine is number 17 with a configuration of 287. You'll realize that chlorine is missing one electron. So if he needs one electron, he will also share one electron. Okay, so if you have Cl2, you will realize that each of these Cl initially miss one electron. They are missing one electron. So what will happen is now they will overlap, and when they overlap, they will share that one last electron in their outer shell. And now if you look at them respectively, all of them will have 8 valence electron. Okay, so if you guys are okay, let me just show you guys how to draw a quick one. So for example, when you look at a compound like water, okay, water is number 1, okay, which means that he will need one more electron to get a full shell. Oxygen is 2.6, meaning that he will need 2 more electrons. So if hydrogen needs 1, he will share 1 electron. Okay, and oxygen, he will share 2 electrons. So there are multiple ways to share 2 electrons. You can either share 2 electrons in a double bond, or you can share 1 electron in 2 different single bonds. Okay, so in this case, of course, our hydrogen can only form 1 bond. So we will have 2 hydrogen, right, that is bonded to 1 oxygen. Okay, so your oxygen will form 2 bonds, right, that share 1 electron each. Okay, so this is how it looks like. Okay, so remember to account for the valence electron. So oxygen has 6 valence electron. There was already 2 that is being used in the covalent bond. So draw out another 4. Okay, so at this point in time, you guys can let the students try the question first. And once they are done, just make sure you check for them. So for oxygen, always remember that there will be a double bond. Okay, so I'll just draw out a simple one just so that you guys are aware of the answer. Okay, and for nitrogen, there will be a triple bond. Okay, so these 2 are parts where students tend to get confused. So you might want to show them how to do it. Okay, so next, right, will be your covalent compounds. So when it comes to your covalent compounds, there are a few things that you need to take note of. Okay, so maybe let me show you what you need to write down for your covalent compounds first. So in your covalent compounds, this is what you will want them to write. So you can either let them, copy it down first, or you can explain it to them first, right? But usually, students like to copy first. So I'll always let them copy first, then I will explain to them. Just make sure everybody copy finish, write finish, put down their pens, then you start explaining. Okay, so I'm going to show you guys how to do it. Okay, so let's talk a little bit about your covalent compounds and their properties. So remember just now I told you guys that when we talk about properties, there's always 2 things we'll talk about. The melting and boiling point and the ability to conduct electricity. So over here in covalent compounds, you will realize that they have low melting and boiling point. So why is that the case? Okay, let's take a look at what was written. So covalent compounds tend to exist as a simple molecular structure. So what is a simple molecular structure? Okay, all these, right, for example, hydrogen, this is what we consider to be a simple molecule. Okay, so what is existing in between them? So existing in between them is this thing called your weak intermolecular forces of attraction. Okay, so the dotted lines that I've drawn is what we use to denote the weak intermolecular forces of attraction. Okay, so students, if you guys don't understand the word intermolecular, inter means between, right? So intermolecular means between molecules. Okay, so when we undergo melting and boiling point, what we actually overcome is we overcome these weak forces. We do not overcome this thing called your covalent bonds. Okay, because your covalent bonds are the ones that will be in between, right, your hydrogens, right, atoms. So over here, this is where your covalent bonds will be, but we will not break your covalent bonds. Okay, so instead we will break your intermolecular forces of attraction. Okay, and then for the next part, you'll realize that covalent compounds won't be able to conduct electricity at all. So why is that the case? It's because covalent compounds will not have any mobile charge carriers, meaning they do not have any ions, neither do they have electrons that are free to move. So because of that, electricity cannot be conducted. Okay, so once you have reached this end, usually there will be 2 questions that I'll get the students to do. So you can see here, this is on page 17, alright, and also page 18. So after they have done page 17 and page 18, then I will actually proceed on to do the rest of these questions. Okay, so the rest after page 19 onwards, make sure you check all their answers beforehand before you start to assign them a mixture of questions from here on. Okay, so usually I'll assign them questions all the way up to 21, 22, but rarely I'll do up to 23. Okay, but all these are spare questions for you to try. Okay, so if you guys have any questions, let me know. If not, that is it for bonding.